We're talking about graphing general rational functions, and we are graphing in different forms. In some cases, we have numerators and denominators that have the same factors in them. In that case, it will help us graph a little bit easier if we can find those factors early. So what we want to do is we want to rewrite f of x in its factored form if we can. So right here, we'll say y equals x plus 2, and then divided by, we got x and x, and we need two numbers that multiply together to 6 and add to -1. So two numbers that multiply to -6 would be 2 and 3. One of them has to be negative. We need a -1 there, so that will be negative and positive. And now what we notice here is that we have some holes, or we're going to have a hole. So anything that cancels in the numerator and the denominator, that is going to be cancel any common terms. So that's what we did there. X plus 2 in the denominator, x plus 2 in the numerator. The terms that are canceled when set equal to 0, those are the holes. So we only have one set there. So the hole in this case is going to be x plus 2 equals 0. So then we can subtract 2, and then we get x is equal to -2. So that is going to be one of the holes. Well, now our remaining function, or the function that we have left over, is we have y equals, in the numerator we have 1, and then in the denominator we have x minus 3. So this is the function that we're going to use in order to finish graphing this. And so for our horizontal asymptote, we know that m is equal to 0 and n is equal to 1. So in this case, we have m is less than n. So if we look at our rules, when we have m is less than n, that means that we're going to have a horizontal asymptote when y is equal to 0. So this tells us for a horizontal asymptote that y is equal to 0. For our vertical asymptote, we're still going to take our denominator and we're going to set that equal to 0. So in this case, our denominator is x minus 3. So then we'll say x minus 3 equals 0. So then we add 3, and we get x is equal to 3. So that is our vertical asymptote, is x equals 3. So we can go ahead and graph those. X equals 3 is a vertical asymptote. And y equals 0 is our horizontal asymptote. We already calculated our hole at -2. We can check our x-intercept. So in this case, we're going to keep using our function. So x-intercept. So when is 1 equal to 0? That doesn't happen, so then there is none. or no x-intercept. And we can pick a couple points to try to calculate, and we'll draw that right in here to try to get a better grasp of what's happening there. And let's try, we need to pick a couple points on either side. So for the x, let's pick 4. 4 minus 3 is 1, so 1 over 1 is 1. Then we can pick 2. 2 minus 3, that ends up being -1. And then we can try 5. That ends up being 1/2. So we have 4, 1, which is right there. And we have 2, -1, which is right there. And we have 5, 1/2. And then we have a graph that kind of comes through and looks like that. And the same thing on the other side. We do have a hole, and our hole is at x equals -2. So -2 is going to be right here. And then we're going to have a graph that goes through and touches or gets that hole but doesn't go through. And then comes up and gets really close but doesn't actually touch. And then we can look at what is our domain, and our domain is defined everywhere except for -2 and 3. So for this, our domain is going to start at -infinity and go to -2. So -infinity to -2. Union, then it's going to start at -2, and then it's going to go to 3. And then union, it's going to start at 3 and go to infinity. And that will be the domain. And then we can take a look at what that graph looks like. So we have it graphed here, and then we have the graph y equals 1 divided by x minus 3. And if we turn that on, we can see that it overlaps directly over what we had graphed there already.